I will be presenting both parts for today's lecture. So this is bold-facing Dong, but Dong lost her voice as we heard, so I'm gonna wing it and also use her slides. So any mistakes I make, any confusion is thanks to me and not to Dong. Yeah, so we'll see how far we get. I haven't timed Dong's part of the presentation, so maybe someone could tell me after 10 minutes so that I have really 20 minutes for this part and I have enough for my part as well. Okay. Yeah, so that's us, Dong, and me. And the first part is going to be about word embeddings and the second part about style embeddings. Okay, so we come from the field of natural language processing, and this is what a typical pipeline in natural language processing can look like. So we have some sort of textual input, then we have an NLP system. Let's assume for now it's like a black box, and then we have some tasks based on that system and text. So we might want to know, what is that text about? What is the topic? We might want to summarize it, we might want to translate it, right? So an NLP system, you might all know, is Google Translate, for example, right? But especially those three tasks, they will be depending on the meaning, what is really said in that text. And if we go to an even smaller unit, what is the meaning of the words in that text? And so, yeah, we could, if we can represent that, we could ask things like, how similar are two words, right? So, for example, Paris to London, how similar are those two words? Maybe it's different than cat to London, and how similar are two documents that we look at, right? And that can be relevant for several natural language processing tasks, like the ones I just mentioned to you. Okay, so when you hear, what is the meaning of words? What do we usually do? Well, we look them up in the dictionary, right? There might be a word we don't know, we can go online, look for it, and find a definition. So maybe we could do that as well for our NLP pipeline, for the algorithm we want to use. But it turns out it's not that simple, right? So unfortunately, dictionaries are somewhat hard to maintain. We might not have all the words in there. And if, in general, would also be hard to make it computationally understandable, in a sense. Okay, so what else can we do? So I'm going to go a bit on a tangent here, and it's kind of come back around to words. But let's talk about vector representations, and that's what it's all about in the end. So if you know what a vector are and you know what words are, I think we're halfway there. So vector representations, you might all remember or know. And what we have is usually at school, for example, we have 2 points defined by two numbers. So A here is defined by 5, 5, and then we can draw a little point in space. And the same, for example, for B here. So this is what we would call a two-dimensional vector, because we have two elements of information in there. Well, we could also make it 3, right? We add just another number that's one more point of information. So this is now a 3-dimensional vector, right? 3 dimensions, you probably have seen at some point as well. And that already is the, let's say, idea here in word representations. So basically, what we're doing in natural language processing, we're projecting words onto vectors. So a point in space. And yeah. And now the question becomes, well, how then? And what does that help us? So here we see cat and dog again, and a simplified, let's say, representation of the vectors, right? You really have, again, the elements as we've seen before, and we got some numbers for each, right, each dimension. And that might really be 300 dimensions, let's say, right? So really something we can draw anymore. And when we have that, we can use them, for example, to do certain interesting things. Yeah, so like I said, vectors are typically 50 to 1,000 dimensions. They turn out to be very, very effective for many natural language processing tasks. But one disadvantage is that the individual dimensions, right, what does the 0.52 mean in the first dimension? What does the 0.32 mean in the first dimension for dog? In comparison, it's not really clear. Okay, so those are the end product, basically. But, okay, now you know that word embeddings are vectors with a lot of dimensions. But how do we get those, and why are they meaningful? Word embeddings are learned based on a lot of text. So we might get that from Twitter, we might get that from Wikipedia, some kind of online resource where we can just crawl a lot of text. Then we have some sort of, let's call it a black box algorithm for now, and then we get these representations that are then supposedly meaningful. If you're familiar, or maybe you've seen these words before, common word embedding algorithms are word2vec, GLOVE, fast text, that are, I believe, still commonly used. Okay, but still I haven't told you how they learn. And that is, what we make use of here is the distributional hypothesis. So if I read the 3 sentences to you here, some believe that Vampas scales have medicinal qualities, approach to fighting Vampos and general wildlife trafficking, even though Vampos scales are made of exactly the. Would you know what that word means, right? Just from reading these 3 sentences. So Vampos is a made-up word. I'm going to tell you that off the bat. And, but maybe you have an idea what it could be. Yeah, I believe this is where Dong asks the crowd, so maybe you have an idea what it could be? Yeah? Yeah, that's right. It's an animal, and in this case, it's meant to be, I've never said this word in English, so I hope I pronounce it right, pangolin. Right there you see it on the left with the scales, like here sitting on the tree. Right, so you had some intuition what the word is, right, just by seeing the words around it. And that's already an important concept, right? You see here the little quote people like to say in natural language processing, but I believe also in other fields, right? You shall know a word by the company it keeps. Which boils down to the distributional hypothesis that we're using to learn word representations. And that is, words that occur in similar contexts tend to have similar meanings, right? So we could imagine having the same 3 sentences just with the word pangolin there. Okay. So that's the concept we want to use, but what about the training data? How can we learn it in the end? What data do we have to use? Do we need to label something? Do we always need to say, well, this is Vampos, this is Pangolin, or something? Well, it turns out it's really, really simple. The text itself, like any text you use, can be used as training data as a form of what we call self-supervision, meaning there's really no annotation you need to use. You just use the text itself as the training data. Yeah. And what a self-supervised task can look like, you see here. So a task which is commonly used is next. It's a question, right? Given a text, what is the word that might come next? Yesterday, I went to the, or a new study has highlighted the positive. Which words do you think might come next? Where did you go yesterday? Museum. Yeah, right? So maybe the museum. Yeah, is that sorry? Supermarket, yeah. So there seems not to be one solution to this. Yeah, right, to the gym, maybe, if you're sporty. To the hotel. Right, so you have some idea which words might fit here, but it's not unique, right? So you get some idea of the distribution that might make sense. Okay, so one of the word embedding algorithms that I already told you the name of, which is commonly known as the first word embedding algorithm, is word-to-vec. So word-to-vector, right? So vector representations. And there are two different training tasks they use that commonly are said within that framework. So CBAL, or continuous bag of words, and scriptgram. And how that might look like is you get some text, one Snowy, and then you have a missing word, she went, and you have that as input. So to, for example, neural network, and then the neural network trains to predict what is missing there, right? Remember, you just take a text that you have, so you know what's missing, right? And you try and learn that exact word. That's continuous bag of words. You can also do it the other way around. You might have the word day and predict what's happening around it. And by training this, you train a representation of these specific words in vector form that you can later on use. Right, I believe I'm gonna maybe skip part of this. Yeah, so now you have word embeddings, which are vectors in space, and now you can do all kinds of fun things, right? You can find the words that are close to it in the vector space, because now you have a number, you can just look around, have some distance metric, right? For example, cosine similarity, and look around. So, for example, for dog, you might find a close word is dogs, cat, here man, cow, and so on. For Amsterdam, you might find the Netherlands, Rotterdam, Dutch, maybe Utrecht, right? So it kind of makes sense in a way, right? You see some related words around it. So those will be words that would have appeared in a similar context, as we've seen with pangolin and the made-up word wampus. What you can also do, for example, is perform algebra. So you can add and subtract different vectors. So here, for example, you have, I believe, companies and their CEOs on the left. Oh, yeah, it's in the caption. And the relationship between, so what you then can do in form of algebra is you have a vector going from IBM to Ramity, and then you can maybe add that same vector to Vodafone, and then you will come about at the same place as the CEO of Vodafone. Or you might have some syntactic or grammar relations that you're also representing, right? So the distance between slow and slower might be the same as between short and shorter. And that would be meaningful, right? And it turns out that this is, what word embeddings can represent. Yeah. There are a lot of fun applications with word embeddings. One of them is looking at semantic change. So you might train these, so you might have text, right, historic text. You have text from the 1900s to the 2000s, and then you can train word embeddings on these and have different word embeddings based on different decades, and then you can compare the representations, right? So you have vectors for the word gay here, for example. You have vectors for each year or maybe each decade, and then you just compare how it shifts through time. And then you find, well, apparently gay meant something different in the 1900s than it does in the 1990s or today. Or broadcast, right, with the introduction of radio and television changed its meaning compared to the 1900s or 1850s as well. So this kind of makes sense. Here's also a representation of that, right? So what you do is basically you have broadcast as a point in space, and then you look at it and you compare it, let's say, in the 1850s, and then you have an embedding in 1990 or something, and then you just compare the surroundings, and then you know, okay, something changed. And then based on how it is embedded, we can also understand how it changed. At what time am I now? And when did? 15 minutes? Okay, great. Okay, you can also, so this is done by Dong and colleagues, add emojis, right? So as you can embed words, you can also embed emojis. They are just the same to computer, right? Just tokens. And here you see from 2012 to 2018, the blue curve, I believe, is frequency, and the red curve is the semantic change score. Of this emoji up there, of this skull emoji. And what you find is that apparently it changed meaning in 2012. What was used more, let's say, literally, close to words like zombie, corpse, bury, and so on. Whereas from 2013 here, it was used more figuratively in sentences, right? So these kinds of things we can find out from corpora from different times and using these algorithms. Okay, so those are word embeddings. Now to do the bridge to what I want to talk about, we can look a bit at sentences, right? So now we embedded words. Great, but maybe we want to know, maybe it's different if you look at sentences compared to words, right? So combining words in a certain way might change, might be different than just looking at meaning of words separately. Right, so before we had an embedding for each word. So bank will have one embedding. But depending on how we use it, it might have two different meanings, right? So today I went to the bank to deposit a check will be something different to the hut is located near the bank of the river, right? And those are really what people have thought about as well, and those that you might want to have different embeddings for those two words, and that's what we call contextualized embeddings. So we also look at the more, depending on the context, a word will have a different representation. Yeah. And then what we might also want is representations for the whole sentence, right? Yeah, I think. Okay. And one key term to use here is BERT, or bidirectional encoder representation transformers, which is a basically a fancy neural network that is also learning, just like we were learning word representations, based on two other tasks, masked language modeling and next sentence prediction. And based on those, we can represent, we have contextualized embeddings like what I told you about before, and we can use those contextualized word embeddings to represent sentences as well. And just really quickly, masked language modeling is the task of just, why it's called masked language modeling is you mask out certain words, so you replace a word by just the word mask. And then the neural network will have to predict what is missing. So maybe similar to this Seabauer skipgram task in a way. And then the other task for BERT is next sentence prediction, which you have a sentence like, the man went to the store, he bought a gallon of milk, and then the task is does one sentence follow the other or not, right? So you have a binary choice. And it can either be the next sentence or it cannot. And again, this is self-supervised learning because you know this from the text you're working with. You know what sentence came after the first. Here, the other example is the man went to the store and penguins are flightless birds, which arguably will not be the next sentence of the previous one. Okay, I think I've butchered Dong's presentation enough, and we'll continue with my part. But maybe you have some questions for this part. I can also just continue and you can ask later. Okay, on to the part I have prepared, which will be about representing style. So now we've talked about representing the meaning of words, the meaning of sentences, if I've been able to get you along with me to that part. But now, right, it might not all be about content. Sometimes we might want to represent other things. So let's look at these, my favorite 3 sentences, and how they might be represented in space, right? So again, remember we are talking about vectors. So you might have a sentence like, oh yeah, and that young doctor got bad hair, and are you one of their fans, or are you a fan of them or something? And you might have an intuition of, right, well, you know that the lower 2 sentences are about the same thing, right? They could be paraphrases of each other. So why are they so far apart here, right? We talked about representing words, representing sentences, talking about meaning. But now I want to talk about style, meaning. I chose an example where this is different. So, and are you a fan of them or something, you can consider as being more informal than the alternative. And this other sentence above, oh yeah, that young doctor got bad hair, is also somewhat informal. So what we want style embeddings to do is to represent similar styles closer to each other and dissimilar styles further apart from each other, independent of content, right? And I've talked to you a lot about different training tasks, and we also do this via this familiar setup of having a training task, using a neural network to do this task, and then looking in the network, taking out these representations that were really helpful for this task, and then using those for the purpose of representing style or meaning, right? In this case, what we use as a training task is the authorship verification task. And this might look something like the 3 sentences you have here. So you have, don't suggest an open relationship if you're not ready on the left side here, and then 2 other sentences. Aren't open relationship usually just about fixing something in the relationship, or it's clear that these are widely different situations, right? And now I could ask you, 2 of them were written by the same person. Would you know which 2 of them?
Yeah, probably don't suggest an open relationship, and it's clear that these are widely different situations.
And why would you say that?
Because the decapitalization at the beginning, or lower, and but still using upper features like the abstraction.
Right. Yeah, that's right. I quickly coded it to show what you were just saying. Yeah, right. So we have the casing, we have the apostrophes, we have no punctuation at the end. So we might guess those 2 are written by the same person, and the other one is written by a different person. In this case, this is actually an actual example, and this is actually the case. And we can use that as a training task for representing style in the end. So we will give the neural network 2 sentences, much similar to this next sentence prediction task we just saw, and ask, are these 2 written by the same person, or are they not? And this is, again, a binary task, and the model will learn some representation internally, which hopefully helps with the task and then helps us represent style. And because this is also a self-supervised task, as long as you have authorship information, this allows for extensive training, just given a bunch of texts. You can also alter this task a bit to make it what we call content controlled. So here in this case, you already see an example that would be that, because the 2 utterances said by the different authors are just about the similar topic, right, which makes it harder for humans as well as for neural networks that were trained on semantic tasks, right, because we tend to really latch on to meaning before we look at other things. Okay, so the model that we trained for this is available online, right? So you can really test this out yourself if you like. And so let's just take the example that I showed you before. And then you can represent those in space. And compute the distances between the different sentences, right? And I wanted to, so here the first one is again more informal, the second one is compared to the first more formal, and then yet we have 2 sentences that are also somewhat more informal because of the oh yeah and the doctor and the missing punctuation mark, right? And now here we have a result. What this is the cosine similarity. A score of 1 means it is the same style. A score of 0 would be it's a completely different style, right? So we have here the most similar, according to this model in terms of style, is the sentence here, oh yeah, and that young doctor got bad hair. And the most dissimilar is actually the paraphrase, which is pretty cool. Because this was really the hard part, making content not count, but making the style count for these representations. So the actual more formal one sentence is really the furthest away from the are you a fan of them or something, while the more similar in terms of informality is more close, right? And adding a punctuation mark increases the distance a bit, going in line with the idea that punctuation is more formal as well. Okay. Now, great, we trained something. We have a representation, we can play around with it, it seems to make some sort of sense. But now I'm telling you, okay, these are style representations. But now, yeah, you might rightfully ask, okay, but how do I know that's actually style? And this turns out to be really tricky because, for one, style is not really uniformly defined, right? So you might have some people that say, well, style is only aesthetic, right? Anything that has function is not style anymore in text. Style might be a socially meaningful clustering of textual features, or it might be all attributes that you can have for text, as has been described in the field of style transfer in natural language processing. So this is really tricky. And the kind of intuition that we stuck with is style should be, or can be anything that's not content, right? So we really wanted to exclude meaning from this and look at style in the form of different way of saying things. And then how you can evaluate this is, of course, just looking at how good these representations perform of the training task, so authorship verification. Is this working well? So this is maybe rather obvious. In another way, I just told you I want style to be different from content. Well, we can also test that, right? So assuming you have these 3 sentences, true, some of them are religious nut bars. All I can say is, got them, you got ragged by class A douchebag. I mean, Judaism and Sikhi also believe that, right? 3 different sentences. I'm already telling you which are the 2 that were written by the same author. But here, what might be confusing, or, well, not confusing, but, right, a model might make the right choice because of different reasons, right? So the 2 green represented utterances are also about a similar topic, right? Somehow religious theme there, while the other one is not, right? So it might make that choice because of that. It might also make that choice because of some stylistic features, right? So like punctuation or capitalization. So that might be a danger of using the authorship verification task as training. So we want to test for that. And that's what we do in testing content independence. So the question we ask here is, are known style dimensions preferred over content information? How much time do I have left? 9 minutes. Ooh, okay. That's less than I want. Okay, well, how... Yeah, well, I'll just skip a few things, I think, thanks. Yeah, so how we do that is we have developed a evaluation framework, right? So you have, again, so these 3 sentences might be familiar to you now. We test basically sentences like these, tasks like these, on that model systematically and check, is it able to use the stylistic information as we test it, right? So, and we make this more complex by having one initial sentence, right? Are you a fan of them or something? And a paraphrase of that in a different style, and a different sentence with different content in the same style. And then we still want the model to prefer that more similar in style but different content sentence. We do this on different dimensions. Won't go into detail about that. Okay, so now onto the fun part. Applications with style representations. So for one, we could try and understand them better, right? So you could go for, you have vectors, right? You can try and cluster different sentences together and really, really probe what they're doing, right? So what we find, we did this a bit, if we have no last punctuation mark, this is really telling. For style-wise, right, this really helps to predict whether the same author wrote two sentences. We have different encoding for apostrophes. We have casing or line breaks that are telling, right? So we can also maybe try that out, right? Right, so we might have this sentence, then we can maybe change something about it. Right, we'll try it with the very same. Well, I said the different encoding of the apostrophe makes a difference, maybe the casing, right? Maybe the punctuation. Okay, so what happens now is that, right, the very same sentence has a similarity of 1. Using a different encoding for the apostrophe changes it, and then having increasing, like the different casing, and then the punctuation mark again moves it further and further away, right? So all these kind of things you can test and try out and see what has an influence. So that's just like, right, using those style representation as a research object to themselves. Then it might also be cool to be able to represent style for research questions like in the digital humanities or social sciences. You can think of things like, well, do people change how they talk depending who they talk to, right? Or does it, do I somehow adapt to my conversation partner? And so on. So let me try and do some live coding. Let's see how that works. Right, so we have this model of style representations that we can really just load with these 2 lines of code. Okay, let me type my 2 favorite sentences. Are you a fan of them or something? Right, and now we can just call model.encode and represent the text. And what we get is a vector, right? Like I talked about, this is really what happens. So we have here, I think, 700 dimensions or something. Okay, now we can encode all of the different sentences I put here, and we can, as before, calculate similarities. Right, and we can calculate the similarities we get here between sentence 1 and 2, right? Those were the different styles, formal and informal. Similarity of 0, which means it's orthogonal, very different. Now we can also plot that, right? So we get the more formal sentences are more clustered together, and the more informal sentences are also more clustered together. Right. And then, so I promised you some, or I promised myself, I'm not sure if I promised you, something to look a bit at how maybe people might adapt how they talk based on their conversation partners. So what we can look at is a convocate data set, conversations gone awry, which is based on Wikipedia talk pages. And people have, Justine Sang et al., they looked at some match conversations that went awry, meaning they derailed into personal attacks, and others didn't, right? So we have that, and they looked a bit into when, right, the first two utterances by the two different people, was that already visible from the very initial interaction? Okay, well, this is cool. Not sure why this is not working, I guess. Okay, well, I wanted to show you an example of a conversation, but I guess you can imagine how people on Wikipedia might talk to each other. Okay. Now, this is the last thing I want to show you. We might want to look at the different conversations in this data set, and let me filter out only those conversations that only have two participants and that have been annotated. Okay, now I told you we have this information. Whether the conversation derails. Which they try in the paper to predict based on the first two utterances. And we can just calculate the similarity score between the first two utterances based on our style representation model. Right, so the first utterance and the second. Right, and if it has an attack, we can add this to a different variable. Okay, so hopefully there's no error because that's how coding works. Right, now we can just, let's try and calculate the mean of the style similarities. Okay, so this is going to take a while. But what we do here is basically we look at these conversations, take the first utterance and the second, then calculate style similarities. And depending on whether it derails into personal attacks, we calculate the mean of the style similarity scores. Okay, this is going to take a bit to look at. I'm almost done. Am I good with time? Well, it doesn't matter now. But it has the what we think style representations also in the field of natural language processing are really promising for is that they have the potential, right, to increase performances of natural language processing algorithms, classification, maybe translation, for diverse demographics and social groups that might just talk differently to, like, let's say, the average internet user for which these algorithms were typically trained. Yeah, and our data and code for this is online. You are welcome to just play with this. Let's see if I'm gonna keep this up. Gonna get the results. And those are the kind of fun things you can try yourself if you like with these algorithms. That's it. If you have questions, I'm happy to answer them. No, you can also just anticipate the results. Well, I mean, what do you think happens? It's also...
Thanks for the presentation. I was wondering, at some point you said that you're trying to process and model style without looking at content. From a linguistic point of view, that is impossible, because style immediately is content. So for processing reasons, I perfectly understand what this is and that you need to conceptualize this and sort of find evidence in patterns, for example. But shouldn't this nevertheless be considered part of content analysis somehow? Because style is a very strategic measure that you use for creating content, right? Even the form of the sentence that you should, are you a fan of them or what, is heavily content-based, even if you're not considering the actual meaning of the words.
Mm-hmm. So you're asking, right, style is part of content.
In a way.
And yeah. Yeah, I think you can see it like that, right? I think it helps to, for us, make this simplifying assumption. And because then you can really test, right, what is happening and try and train for it. But indeed, I mean, also our representation is not independent of content, right? Even when we look at our evaluation, the content is still often preferred, right? Content cues. So I think eventually that is something to think about, but right now with these initial representations, we're far from getting into the nitty-gritty, and it's enough, like, right, this is somewhat of a paraphrase and differently written, so this is, we assume it's just same content. Yeah.
I have a practical question. So style, you had a lot of data, but what do you think is the limit if someone's interested in style that, yeah, where's less data available? So what are the limits, would you think, how much training or how much data is needed to follow this approach? Or is it just that you could say it's formal and informal, and so like only this binary broad thing, or do you think it could be more fine-grained?
Yeah, I'm not sure I heard all of your question there. So you're asking how much data is needed for training this?
Yeah.
Well, the typical natural language processing answer is as much as you can get.
Still some numbers.
Yeah, so we train on, I think, 500,000 utterances. And there is evidence to, like other people I've talked to who've trained like representations, that it helps to use many, many more. So we're talking then millions, billions of utterances, right? And I'm not sure what the minimum would be, right? I guess yeah, but I guess I would recommend at least train with as many as we did. But yeah, maybe it works. Has interesting results also with less. Yeah, I can't be sure.
So that would mean it's probably not possible to, to train on the style of a certain single author. Or maybe if there's a lot of, so I don't know how much is.
So you would want to represent an author, let's say. Yeah, that's something people have looked at as well, right? We want to represent not authors, but like something more general. I think you need more data with that, but for representing authors, people have definitely looked into this. I don't want to say anything wrong, but I believe you don't need as much necessarily for that. At least there's work into trying with less, right? Yeah.
This kind of goes with the questions that you guys are asking. I'm curious in terms of like the range of stylization that you guys are looking at right now. We're talking predominantly about like whether or not you use capitals, whether you truncate certain things. But style is just like such a vast kind of thing, right? Everything from indicating like regional things, like I don't know, like say in California with front-hair vowels, so we'll spell something related to front-hair vowels, or we'll use specific like lexifiers, or we'll like truncate certain things that maybe other people won't truncate.
Right.
And I'm wondering like what that range is, or if it's predominantly like these things like are you like coming here with an R and a U, and keeping in mind that there's like a lot of like style switching where like if I were to put RU at something in front of something, that is in some way a joke about like bold text speak.
Right.
So I'm wondering like the kinds of applications that you can do and the range of stylization that you can look at.
Right. So what variety of styles we can represent, and what we can do with that, right? What applications is that? Yeah. So the short answer is I don't know yet, right? I mean, we only tested on very much, right, data sets that were easily available, formal, informal, right, complex English, more simple English, for example, where there's not yet a lot of variety. So that's to be tested, to be found out. My assumption is that with this model, not trained on that many utterances, you will have not that much variety represented, as you could, definitely. But I think you can, my guess is you can probably represent a lot, but the tricky part is extracting that again and evaluating it, right? And in terms of applications, well, I tried to show a bit right here. We get some results. So the similarity for the conversations in attack is not as high as for those that remain civil. So I guess you could look at these kind of questions, but I think it's also more basic than that, right? So as you have, I'm not saying that the model we trained is going there, but right, the way you have the very basic sentence representations or word embeddings in the field of NLP, which has a huge effect on all kind of downstream tasks. This might also have a huge effect if you can represent it well, and maybe in the variety we were talking about, this might be really helpful to a huge amount of tasks because you can more cleanly represent what someone is saying, right? Not just the content, not just the style, both, right? And then be really good, for example, with tasks like machine translation, with tasks like understand, right? Just interaction, for example, human-computer interaction would be a lot better. That's the NLP side of it, and I hope you can maybe be creative in the parts of other fields where I'm not an expert, but I hope that there you can also use these representations, maybe even as research objects to themselves, as soon as we're confident they really represent something that's meaningful, right?
Your Jupyter notebook, if he had the data in the appropriate input format, the data in another language, could we plug in some other pre-trained data? Or so how adaptable is your code?
Right. So you're asking to train it on a different, for example, language, like German, for example. What I just showed you, that's for like a fixed model, right? This is already trained, and you can easily call it and play around with it with a few lines of code. If you want to adapt it to your own language, this is also possible, right? But this is more tricky. Right, you need, for one, you need to have your data in a certain input format. Well, this should be a bit, it should be doable. But then what's the tricky part is, not tricky, but in principle, everything is doable. Let me put it like that. But you need some sort of infrastructure, right? A computational infrastructure to be able to train. This is not pre-training, it's only fine-tuning, so this should be accessible. But still, right, this is the part that will also take some time. And then the tricky part is evaluating it, right? Our evaluation approach is based on English data sets. Like these parallel data sets where we have the same like content paraphrases, like written more formal and more informally. I'm not sure if that something like that, for example, exists in German or in another language, right? So it would be hard to evaluate in the end. You can still, right, assuming the same approach works well for all languages, and we have evaluated it in English, you could try it with another language and hope for the best, but it's at least something to think about.
Newspaper articles, everything that the man wrote back in the days, and we have access to the entire corpus of Dickens texts. This would be something maybe worth giving a shot at, right? Like using this to look into different representations or ideas of styles in Dickens text.
Yeah, so you would be wanting to represent, let's say, different genres for Dickens, for example.
Mindsets in writing or sort of audiences that he writes for.
Yeah. I think for sure. I mean, these kind of you would for sure need to train it, retrain it. Yeah. But yeah, I think this approach is rather general. I think in authorship representation, they have used similar approaches for representing authors, and I'm sure you could also represent.
Turn it around and then. Yeah. Okay.
Yeah.
I'll put Flame into contact with you and done. Thanks.
Yeah. Cool.
What do you think? So we also have models that work on larger portions of text. Do you think that could be So if the embeddings capture more than one sentence, could that be an add-on, or is this would it generalize too much?
So.
And how would you, or would you rather use another method to combine information from, or the results of different sentences and then combine them to kind of describe a larger portion of text? So outside the model
So when you say larger portions of text, how long would you think?
Or even
Paragraph?
one page, or even longer.
Yeah. Okay, yeah, to represent paragraphs, I believe, so we have here a limit of, I'm not 100% sure, some 100 tokens, 700 or something, but this could already be paragraph, right? So we can actually represent something longer than sentences. And in fact, I only showed you sentences, but we also trained on longer than one sentence utterances. So that would be possible to go for whole documents, maybe. I guess you would probably need to go with a different model, but let's say, I think that's possible because we have like transformer-based architectures as well that are made for working on documents. Yeah.
But what is your feeling with respect to modeling style? Would it
Right.
make sense to look at larger portions
Yeah.
of text, or?
Yeah, does it make sense to represent style for a whole document, for example?
Or should it be measured on the sentence base and then kind of combined outside the measurements?
Right. I don't necessarily think it would be better to measure it on sentences and combine it to represent a whole document. That's what you were asking, right?
Yes.
I think, I mean, I don't know, right? But I would guess it makes more sense if you want to use it for documents to really train on documents. I think you will represent something different then, right? Maybe more idiosyncratic things, right? Because if you can imagine if you have a whole document, there will be more combinations of features that are more telling of one specific person than when you just have one sentence. And maybe then you just represent something different.
Maybe the text type.
Right, yeah.
Style.
Yeah.
Yes. 2 points, and thank you for this. One is related to Christoph's discussion or pointer about style and how style is conceived. Of course, there's a very wide range of definitions of style in linguistics and social linguistics. But I think it's fair to say that the understanding of style in social linguistics has shifted towards style, viewing style as a social practice, and being more interested in co-occurrences of different features across different levels of structure in constructing something like a social style. So, but at the same time, I think it's a matter of definition and of finding the right definition that suits your aims.
Right.
So maybe lexical style in that sense. But related to that, and also to the last point, I realized this time and also yesterday in your internal presentation that in your examples, you're only sort of testing one dimension of variation, which is from a more formal wording to a less formal wording,
Yep.
Related to lexical choice and also to spelling variation. I wonder whether you've tried out other dimensions of lexical style or lexical variation, such as from a more contemporary to a more archaic, or from a less technical to a more technical. Or maybe from a standard super regional lexical style or lexical choice to a more regionally marked lexical choice. Because if you're really interested in lexical style and as a more precise definition of what you're looking for, then these are the standard axes of lexical style have been so for decades now, and you find this in dictionaries as well, right? With all the stylistic markings in dictionaries like archaic and neologism and things like that. So would that be a direction to work with?
So you mean using, right? So we were hinting at that they only showed informal, one-dimensional changes, yes, right? And that what about other style dimensions, let's say? Yeah, I think we tried from the ones you mentioned, we tried, let's say, like this more, maybe most connected to what you said about technical versus more easy phrasings. So we used Wikipedia, like normal English Wikipedia and simple English Wikipedia, evaluated on that. But yeah, that's where, for the ones you mentioned, it stops. And for sure, it would make sense to try, for example, more standard or original phrasings, or more like, different styles from different times. Let's put it like that. Yeah, I think that makes sense to test. And in the end, you could also argue for maybe someone wants representations that just represent one thing, right? You just want formal or informal, and then you just test on that, and you want the others not to be represented.
It all depends on the training data, right?
Yes.
So I'm being completely ignorant about the details of the method. I think one thing you would even use in train such a model would be different editions of literature classics, like for kids, for example. So if you take a standard literature classic in its standard edition, maybe from a past century, from past time, and then you have a more modern translation, or maybe an edition for kids. There you have basically similarity in contents, well, not at the level of each and every sentence, but at the general content, and then you have different lexical and syntactic styles oriented to different audiences in different ages, and also of different ages and at different points in time.
Yeah.
So maybe these things could be used as training.
Yeah, definitely. Like the training data has a huge influence. Yeah, I was talking about evaluation, which is a different challenge, right? But then you can test for it and then find out it's not there. Then you still need to find out what training data will help represent the styles you want. And I like your idea with the parallel corpus of, right, kids versus classic. Forms of the same story. I think that's a good idea to try. Yeah.
Okay. Thank you very much again, Anna.
Sure.